For these piecewise function video notes, we are going to concentrate on these three questions. Can you graph a piecewise function? And when I ask can you graph one, I mean both by hand and by using technology, whether it's Desmos or the graphing calculator, and I'll show you how to do both. Can you look at either the equation or the graph and determine if it's a function or not? Most of the time they tell us it's a function before we start with it, but this one right here is not telling you it's a function. So can we look at this equation and help and determine if it's a function? Can we look at the graph? Then we're going to learn how to evaluate the relation or the function, either one. We're going to evaluate it by using the equations or by using the graph. You should know how to evaluate either way. So I want to do this on all of them. Yes, I realize you have the graph, but I do want you to see how it's graphed by hand. So I'm going to bring this over here and we're going to real quickly graph this one by hand to show you that you really already know how to do this. So this first equation right here, I'm just going to pretend the equation was just y equals 2x. I'm not going to worry about the restrictions. I'm not going to worry about this other part right here. I'm simply going to graph y equals 2x. So y equals 2x is in slope-intercept form. This number right here, the 2, is the m, and there is no b, so that means the b value is 0. So I start by putting that 0 right there, and then since the slope is a 2, that means I'm going to, from this dot right here, I'm going to rise to run 1 and put a dot. And then I'll do it again. Rise to run 1, put a dot, rise to run 1. I'll do that all the way across my page until I have a good enough sampling of dots in both directions. And I will attempt to draw a straight line. I'm not going to worry about it too much because I'm going to erase a big portion of this, but there's the line. I'll change colors and draw the other equation, which is y equals x. So that's an easy equation to graph. Y equals x is with the green part. And so that has a y-intercept of 0 and it has a slope of 1. So again, start at 0, 0, rise 1, run 1. That's the parent function, so we all know what that looks like. And it goes this way. So it looks like a system when we first graph it. It's not a system, however. It's just considered one relation, because we have graphed too much. So this first equation right here, they don't want the entire set of x values. They only want the x values that are less than or equal to 3. So for example, this one right here, this x value, this one, or this x value right here, this one is 4, where is that point? This one is at 4, 5, 6, 7, 8. This one is at 4, 8. They don't want that x value right there. They don't want that point, because why? This x value, which is 4, is bigger than 3, and they only want numbers that are smaller than 3. So what we have to do here is we have to go back and erase, not the whole line, but we want to erase all the way down to where our x values are 3, and then we only want to use the ones that are 3 and less than 3. So we're only going to graph this portion of that line. Okay? Now for the green one right here, the green one, they don't want every x value. They only want the x values that are greater than or equal to 2. So I'm going to go over here and I'm going to erase the x values that are smaller than 2. Well, here's the x value, here's 2. All of these x values are bigger than 2, so we're going to get rid of all of these x values over here. Now it's going to erase the line, but I'm also going to erase that point. Okay, so I've erased all the points, and now the only one that I want to keep are these right here where it starts, where the x value starts being 2, and all of the ones that are this way. So hopefully now this graph right here it makes sense with this one right here. Okay, so let me move all this out of the way. So you can kind of see where those came from, right? So that's where they got this. They graphed that equation into parts. I'm going to jump over now to Desmos and show you, I lost it, and show you how they did it on Desmos. So as you can see, here is the equation right here that they gave us to graph, and I went and typed that in. Now, I didn't put the y equals, but you certainly can. You can put the y equals. Nothing changes when you put the y equals. You cannot put it on the same line. You do have to take these two equations and put them on separate lines. These restrictions that they gave us over here, the x is less than or equal to 3, that has to be inside those braces. If you leave those braces off, then it gives you the whole line. So to graph the braces, you just use the braces on the keyboard, and you just type in x, whatever they tell you, is less than or equal to 3. And if you're typing that in on your calculator, you use the less than symbol. Then right after that, you hit the equal symbol and it puts the bar underneath it. Okay, so that's how to graph it on Desmos. You can graph it on your calculator, but I am going to show you how to do that in a minute because it does something weird on your calculator. And before I show you what it's doing weird on your calculator, I'm going to need to show you another part of this.